Hello friends, welcome to my channel. In this video, I will cover engineering mechanics part 3. So here in this question, the block shown in the given figure is kept in equilibrium and prevented from sliding down by applying force of 500 Newton. The coefficient of friction is root 3 by 5. The weight of the block would be how much? So block is sliding downwards, so frictional force will act upwards. This direction you will get frictional force. Weight or mg is like this, and mg cos theta. This direction mg cos theta. Normal reaction this direction n. This angle is cos theta. Sorry, this is theta. And mg cos sin theta you will get this direction. Axis we will choose like this, x axis and y axis. So first along y axis we will do fy equal to 0, mg cos theta equal to n. So n equal to mg cos theta. Then along x direction we know frictional force is mu into n. Mu is your coefficient of friction, it's root 3 by 5 into m is mg into cos theta. Theta is 30 degree, so mg root 3 by 2. Along x direction mg sin theta, it's equal to frictional force plus 500 Newton. Then frictional force we already got, mg sin theta we can write 30 degrees, so 1 by 2, it's equal to frictional force is 3 by 10 mg plus 500 Newton. We have to calculate mg value, so this side we will take mg 1 by 2 minus 3 by 10, it's equal to 500. If you solve this one, you will get 500 into 10 divided by 5 minus 3, it's 2, so 2500 you will get. B is your answer. Question is, a box rests in the rear of a truck moving with a deceleration of 200 meter per second square. To prevent the box from sliding, the approximate value of static coefficient of friction between the box and the bed of the truck should be how much? So let this box is like this. It's moving with deceleration. Frictional force this direction, then normal reaction n, w or mg. In this given, this is mg, so it's equal to 0, n equal to mg, and frictional force mu into n or mu into mg. Then along x direction ma, it's equal to frictional force, it's equal to mu into mg. Mm cancel, mu equal to a by g. Acceleration given in this question 2g, g value not given, so let it be 10, 0.2 approximately. So here 0.2 available, so you can answer B. In an automobile having a mass of 2000 kg cruises at a speed of 20 meter per second, if all the wheels are jammed suddenly, how far will the automobile skids before it comes to a halt, assuming that the vehicle does not spin or topple? The coefficient of friction between the ground and the tire is 0.8. So work energy principle we will use here. kinetic energy initially, potential energy initial, spring is not available, so leave it. Force, external force into displacement is equal to kinetic energy at 2 point or final point, potential energy at final plus frictional force into displacement. So its halt means kinetic energy at 2, V2 is 0, so this is 0. Potential energy you can cancel, then half mv1 square, no external force, so F also 0. It's equal to frictional force into D. Given mass, given half mass is 2000 into V square 20 square, directly I am writing 400 into frictional force is mu into N. N is your W or mg. Frictional force is mu into N. Normal reaction is mg, the weight of the body. So you can write here mu mg into distance. So we have to calculate the distance. Mu value given here, no need to write this one. We can cancel. G value not given, so write it as 10. Mu given, you will get 200 equal to mu value is 0.8 into G, let it be 10 into D. D equal to, you will get 20 by 0.8 or 8 by 10 you can write. It's 25 meter. B is your answer. Question is, a train of weight 200 into 10 to the power 4 Newton is running on a horizontal track at a constant speed of 10 meter per second, overcoming a constant frictional force of 20 into 10 to the power 3 Newton. What is the power of the engine driving the train? So power W is given 200 into 10 to the power 4 Newton. V is given 10 meter per second, then frictional force also given 20 into 10 to the power 3 Newton. We know power equal to frictional force into V. Frictional force is 20 into, all are in kilowatt. Okay, meter per second. So 10 you multiply F into V. Kilowatt means 10 to the power 3. 200 kilowatt. C is your answer. Question is, a wheel of mass m and radius r is in accelerated rolling motion without slip, under steady axial torque T. If the coefficient of kinematic friction is mu, the friction force from the ground on the wheel is how much? We know frictional force is mu into N, normal reaction is mg, so mu mg. A is your answer. Question is, a block of mass 5 kg is thrust up a 30-degree inclined plane with an initial value of 4 meter per second. It travels a distance of 1 meter before it comes to rest. The force of friction acting on it would be how much? So its initial velocity V equal to 4 meter per second. Let final position this one. This is its final position. So this is the vertical distance moved is this one. Let this is h, and this distance given from here to here, it's 1 meter. See 30 degrees, so h value also you can calculate. H you will get 1 by 2 meter. Then we will apply our work energy principle. kinetic energy, potential energy plus force into distance, it's equal to final kinetic energy plus potential energy plus frictional force into distance. We have to calculate frictional force. Initially no external force, so first I will write the equation half mv1 square plus mg, let this height is, okay, leave it, mg h1 plus force into distance half mv2 square plus mg h2 frictional force into distance. So here it's at rest, so mv2 square is 0, mg h1 minus h2, this point is 2 point, this is 1 point, h2 minus h1, so h1 is this height, h2 is total height, this is h2, so h2 minus or h1 we already got, it's 0.5 meter, no external force, so this is also 0. Then mass given half, mass is 5 into velocity is 4 square, mg h2 minus h1 directly we will do, so m is 5 into g, we will take 10, h2 minus h1 it's 0.5 or 1/2 meter, already I got this one, plus frictional force is mu into n. Frictional force we have to calculate, friction force into distance moved to 1 meter. 1 meter. If you solve this one, 2, 16, 8, 8 into 5, total you will get 40 this side. This side it's 1/2. 5 into 5 it's 25, 40 minus 25, frictional force equal to 15 Newton. This is your answer. This is the end of part 3. Thank you friends, thank you for watching my video, thank you.